You're listening to a podcast from the University of Manchester.
This episode was recorded during lockdown. Please forgive any issues with sound quality.
Welcome to this episode of The Buzz. In this episode, we're talking to a couple of PhD students from the Have You Heard team. They're a podcast group that look at how science is portrayed in the media and delves into some techniques that we can use to see how trustworthy science is being presented. To begin with, though, Joe and I are going to be playing 2 truths and 1 lie with some scientific facts. So Joe, do you want to go first?
Yeah, I can go first. So, see if you can guess which one's the lie. In 50 years, humans have decimated 2/3 of the world's wildlife. Okay, next one. Dogs can sense heat with their noses. And third one, worms once had lots of tiny, tiny feet.
I hope the first one's not... Wow, I hope it's not true. I think it could be worse than that. So I'm hoping it's not true. It's way less, but maybe it's not. Dogs and heat through their nose. I mean, that could be true. They don't sweat, do they? That's what always panting. So maybe, I don't know if that's got to do with their nose. What was the final one?
Worms once had lots of tiny, tiny feet.
Worms and feet. I think that might be the lie. I know snakes they're not worms. Snakes aren't worms. They're totally different. But maybe you read that snakes had feet and were like, oh, I can trick Corey by saying worms instead.
I'd never presume I could trick you, Corey.
Oh, well, of course. I'm going to go with the worm fact as being not true.
As the lie?
Yeah.
You are correct. That is a lie.
Good.
I completely made that up. And yeah, it sounds a bit ridiculous.
No, it sounded, like I said, snakes used to have. So you see the bones still in the skeletons for the legs they had.
Yeah, that's what I thought. It could maybe be plausible. Unfortunately, the first one is true. So since 1970, I'll check my notes here. The population sizes of 4,392 mammals, amphibians, birds, fish and reptile species declined by 68%.
That's so bad.
I know, it's terrible. And that's according to a World Wildlife Fund report from 2020. And the dogs one, also in 2020, researchers at Lund University and Jotvos University, they found that dogs are able to sense weak thermal radiation with their noses. Only a few animals can do this, so some snakes and the vampire bat. But it's important because it could be a lifesaver because newborn puppies struggle to open their eyes, so being able to smell heat can, help them avoid danger. That kind of thing.
That's cool. Well, ended on a more positive fact, I guess.
Yeah, that's a nice fact.
Yeah.
It's a shame about the worms one because I was picturing them with lots of tiny little legs. But
sure, but you made it up.
Yeah, I did make it up. But you got it right.
Yeah, well, I'm pretty good at these games now.
I know, I can see.
I've got 3 statements, one of which is a lie. Okay, first up, all the matter that makes up the entire human race could fit into the space of a sugar cube.
Right.
Another fact, leeches have chemical memory, which means you could feed a leech to another leech and they would have some memory of the previous leech's life.
Oh, wow.
And the final one is, if you're in a low light situation, your vision becomes worse when you look directly at an object as opposed to kind of looking at it at an angle or kind of in your periphery vision.
That is tricky. The one that sounded a bit too mad was the leech one, I think.
Okay.
So what? It can take on another leech's memory by eating it.
So I will give you some background to it. some experiments in the 50s and 60s. Some scientists were trying to discover if how memory kind of exists in the brain. And so one of the hypotheses were that it was like chemical. So you would store chemicals in your brain, and that was your memories. And so they did an experiment where they had Leach do a kind of go through a maze. And so they had some blood at the center of the maze, and the leeches worked out where the blood was in the maze. And then what we did is they liquefied that leech, fed it to a different leech, and then they gave that new leech the same maze. And because it had the memory from the previous leech that they had just eaten, they could do the maze really quickly because they knew where to go.
Right, wow. See, now this sounds like you're not making it up because it's too detailed. And the other one was the ice cube. See, that's incredible. If
It's a sugar cube.
Sugar cube.
Yeah.
That's incredible if it's true. And what was the last one again?
That was the when it's dark or low light, you should be looking kind of at a side to the object, not directly at it.
Okay. Oh, I don't know. I'm gonna stick to my original guns, and I'm gonna say the leech one, but only because I'm thinking you're trying to trick me. Maybe they tried to see if it would remember it, and it didn't actually remember. So I'm gonna go with leech.
Okay, you are correct on both fronts.
Yeah.
So
yes.
The experiment did take place, and to be fair, the scientists declared that they had memory, so that you could liquefy the leech and feed it to them. And so it was quite a big thing. But then numerous experiments since have kind of not found the chemical memory thing to be real, really. So they thought at the time, well, if this is true, then maybe we can apply it to humans. We'll be able to take memories from people's brains, their chemicals, and give them to someone else. But it didn't happen, so it's a bit made up.
Yeah, I think that's why, because I thought people would try and use that on humans as well, and I've not heard anything like that. It sounds like something off Harry Potter.
Yeah, so the sugar cube one, that is true. So most of atoms, like 99.9% of atoms, are just like dead space. So from the nucleus to the electron, there's a massive gap. I think it's something stupid like if you had a football in the center of a football stadium, then the nucleus was on the center field spot, and the electrons would be outside the stadium. Like the gap between them is that large. Don't know if that's exactly true, by the way, that analogy. So maybe that's more fake news, but like that scale anyway. And the low light one, yeah. So how we see in the dark is through rods in our eyes. They're the ones which detect color. Not color, sorry, light intensity. So the cones are for color, rods are for light intensity, and all the rods in our eye, they are on the edges of the retina, so they're not directly at the base of the eye. And so if you're looking directly at something, you've not got a lot of rods there. In fact, you've got more rods at the kind of on the periphery vision. And so if it's really low light, you need that light intensity into your retina, then it's better to kind of look to the side of it because that's where you've got more rods, so you should be able to see it better.
Right.
Yeah.
Nice. Yeah, good facts.
Yeah. So, Joe, we were playing that game because we were looking at how fake news could be spread. One of the ways in which fake news is potentially spread is through science in the media. And in this episode, we spoke to the Have You Heard guys all about this. So we are joined today by Luke and Katie, who are from the Have You Heard podcast team. Do you want to give a little bit of background to who Have You Heard? That's hard to say. Give me some background to who Have You Heard are and what kind of your goal is.
Yeah, certainly. Katie, do you want to, or shall I?
You go for it, Luke. I tend to talk more than you.
So Have You Heard is an organisation set up originally at the University of Manchester by a group of PhD students. We're now spread in all sorts of different places, mostly in Edinburgh, Glasgow, and Manchester. And the guiding principle is dealing with science in the news. So major headlines that come out about scientific discoveries and kind of informing the public about how you can sift through what might be sensationalized headlines or things that don't quite match the science that's going on, and how to deal with that. In particular, we try to target groups who aren't typically targeted for kind of science communication stuff. So we've done things in local community groups, mostly. So people like working men's clubs, retirement homes, things like that.
And also with Have You Heard, Luke and I teamed up and set up the Have You Heard UK podcast, where we talk to experts in their field and discuss particular headlines that have come through within that field. And we work through those headlines and the articles together to figure out what's true science and what may be sensationalized, and just sort of have some fun along the way.
That's great. I guess before we go into the how to read the science in the media, then, I guess why is this important? Why should we be even concerned about this?
It's such a good question. So science informs so many aspects of our lives. It affects what you eat, what kind of air you're breathing, what kind of medicines you have, how you live. It's honestly everywhere. And your understanding of science is therefore really important to be able to make rational and informed decisions without being scaremongered or pushed into doing something that sounds like the right idea based on how someone presents it, but actually it could be detrimental to your health or your surroundings or your well-being. So science is just an integral part of life, and in order for a progressive society, there's constant progressions in science, and that's really important. But I would argue that the other side of the coin is being able to communicate that science effectively, because there's no point doing amazing research if nobody knows about it, because the whole point of doing science for the most part is to help people and to make the world a better place. And you can't do that through research alone. You also have to be able to communicate that research.
Do you think it's fair to say that science and the way kind of science is it almost more important for science stories to be accurate, to have that focus on accuracy more than other types, given that if, depending on figures or whatnot, they need to be correct, because an inaccurate figure makes a big difference whether they're right or wrong?
Yes, completely. And not necessarily because of the straight output of a figure that may be informing someone in a different way than the truth would have done. That's one argument within itself. But the other more important aspect is then if you get a climate where science is being portrayed inaccurately, you lose the trust of the public, and then the sort of the credibility of science also becomes diminished, and then you enter a society where informed decisions are difficult to come by.
I think just adding to that is, talking about kind of credibility is, at the end of the day, the vast majority of science is funded by the public. So the money for a lot of the research comes from kind of tax-funded and charity organizations. And it's important for everyone to, if they want to be able to understand what scientists are doing with those resources. Science isn't just its own kind of section of society getting on with things and discoveries and things. It's something for everyone to share in and find out what they're doing and what's going on. Great.
And I know you touched on funding there. Should we in general be kind of concerned about who's funding the study? Could there be any examples of bias being played out at all?
Yeah, that's a really good point. So all scientists, need to earn money to live, work and eat, just like everybody else. And therefore, you need to be aware of who funded a particular study. So any academic publication will have a funding disclaimer, and it will say this was funded by the British Council of Research, or a particular partially funded by a certain industry, or whatever it may be. And that's something that should be communicated through to the public, particularly if it's a controversial study. So I think one of our previous episodes had a really good example of this. Do you remember, Luke, to do with eggs for breakfast? So there was an article that said something along the lines of eating a full English breakfast with eggs every morning is good for you for various reasons. And then little disclaimer at the bottom, funded by Lion Egg Company. And
Wow.
you just go, okay, it makes you a little bit more skeptical.
Yeah, it's important to declare anything like that where research is funded by a particular company. It doesn't necessarily mean that there's anything wrong with that study. A lot of, obviously, that kind of study would only really be of interest to people who produce eggs and things like that. But it's important, you've got to be reasonably sure that, for example, the article would have been published regardless of what the outcome was. It's an important one. So a lot of the time it'll be a group of scientists get funding for a project and then they get to go do that project, and they don't have to report back with what their findings were.
It touches on the importance of publishing negative results as well, which is something that is becoming more of a thing in science nowadays. But one of the problems with the pharmaceutical industry is that there is only largely publication of positive results, and it means that competitive companies and competitive research labs may be working on the same thing that someone has already disproved, but because it wasn't a positive result, it doesn't get published.
Yeah, and kind of on the back of what you were saying before, if it's a controversial result, so if you've got a large body of research that says one thing, and then a study that's funded by a particular company goes the other way, then it's something where you should be very skeptical of, ignoring the consensus just because that one company happens to have found some evidence about it not being the case.
It's also important that it's stated who it is funded by, to keep some reliability and honesty from that company. It sort of forces them to be accountable for their work.
Yeah, I guess historically, like companies, tobacco companies, right, had sponsored studies into the link between tobacco and cancer, and often those studies would find in favour of the tobacco companies and minimise the risk of tobacco smoke. And so I guess there's a real world consequence, right, of not disclosing funding properly. And so it had a knock-on effect of actually tobacco not being linked to cancer for a very long time because of that.
I was going to say quickly off the back of that, the issue with the tobacco situation, if I remember correctly, is that even once a link had been very well established, tobacco companies would effectively fund a lot of further research, because a common phrase that crops up a lot when scientists are looking into something is you'll manage to show a link in a very particular set of circumstances, and you would commonly say, oh, this is encouraging evidence of this pattern we've noticed, we want to do further research. And what tobacco companies did is effectively used that as a form of propaganda. So being able to say the headline, scientists want to look further into the link between smoking and lung cancer, for example, that sounds like it hasn't already been decided. And it's the same thing where you need to give the context of the field in general, as well as not just one particular article, because you can use that to your advantage.
Because also you can make a particular piece of science sound amazing, like it's this brand new idea, but it's actually been established in the field for a long time, and it's just another piece of evidence going on to that. And that sort of adds to the problem of science communication sometimes, in the idea that these things happen instantaneously, rather than being a combination of years and years of work. I think also there's plenty of historical examples of where, depending on where the political power and funding is, you can vastly influence the research that is being done, and also the outcome of those research. So, for example, Nazi Germany is a a classic example of science being taken and really heavily biased, but based on a political agenda.
As well as the actual funding, should we consider the journal that the research is being published in for validity and accuracy?
So we personally would advocate for every sort of headline that's discussing an article to link to the academic article. And we always think it's a bit sus when they don't, because it's a bit like, what are you trying to hide? But in terms of the prestige of a journal, there's swings and roundabouts with that. So some journals that are classed as very prestigious, for example, Nature, sometimes they are those. There's a statistic like something like 50% of the research published in Nature has not been able to be repeated, and it's because of this prestige that they'll only publish the best and greatest, and so the newest stuff, which a lot of the time actually ends up being really difficult to replicate. So there is a conversation to be had about how much you take into account the prestige of a journal, and also whether or not it's open source. So it's historically difficult to get into the more prestigious journals, which tend to be closed source, and a lot easier to be accepted into an open source journal. But that doesn't necessarily mean that it has a less rigorous review process. So that's basically a very complicated question, and you expect a lot from the lay reader. So we would just advise that if it says where the journal's from, and especially if it links to it, if you are interested, go and have a read. And if it links to it, it's probably more likely to be trusted.
Yeah, I like you say, I think it's really difficult for anyone just reading a newspaper article to decide whether or not a particular journal means much. I would generally err on the side of I wouldn't worry too much about it. Certainly, like Katie says, it's a nice sign if they link to it. If you can find the actual scientific article they're talking about, that's really nice. But yes, even scientists, there's a lot of debate about what makes a good journal and what doesn't. But I think you should be careful about very small niche journals sometimes. Like you could, if you look into it and it's, by the University of Things My Mum Told Me When I Was Little, it's like you get that kind of thing. And I think something that'll come up repeatedly with our answering questions today will be that the main thing to look for that kind of thing is there someone else that agrees, that has nothing to do with the original study? Is there someone who's kind of qualified to commenting on it and saying, yeah, this sounds about right? That's something more important than the journal.
Experienced researcher in the same field who is independent to that original study. Having a quote from someone like that adds much more weight to the validity of that science than just simply stating which journal it was published in.
Yeah, again, it can't be my mum.
Sure. And so that's one of your toolkit things, right? Is who else is talking about this research and are they agreeing with it? I know another one is where in what, I guess, what is the research being done on? So is it being done on a cell petri dish? Is it being done on an animal? Is it being done on a human? I guess, can you talk about that and kind of the importance of kind of having those stages of researching and ascribing importance to different levels of importance to the medium in which they're being researched on?
Of course. So both Luke and I, our background is biology. So that's why we mention things like the cell, a petri dish, and a human. And that's because if you want to, for example, take the case study of trying to get a drug into a human, there is basically a 20-year research pipeline in which you start with a hypothesis about creating a certain drug, molecule, protein, and then you've got to produce that synthetically, put it into a cell, see whether it dies or not, see whether it has the appropriate response that you want to see at that small level, bring it up into higher studies, and then again into animal studies, and then finally into humans, and then into sort of population-wide data for broader things. And each individual step of that process is really important. And every time that there is a therapeutic for example, cancer, if it passes through any of these stages, that's really great and really interesting news. But for example, if it's in the earlier stage and it shows that a certain drug is blocking a certain cancer pathway, for example, a headline may say, cure for cancer coming soon. And then people will think, 5 years time. And in reality, it's not even been in animals yet. It may cause, immediate kidney failure. And it leads to this society where more and more now you see headlines that say, cure for cancer in 5 to 10 years, potential new cancer cure for the common cold comes up every winter time. And you think, I'm sure, didn't we cure the common cold like 20 years ago, according to the Daily Mail? And it's because those original headlines sensationalize it from those first points of study, and they've still got further to go and points where it may fail. So it's good to sort of ground yourself when you see a sensationalized headline, to be like, okay, where in this pipeline is this? And we use the example of cell, petri dish, animals and humans because of our biological background. But the same is the case for all science. It can be, has it been done on a computer model versus have we got experimental data? Has this been reproduced? Is this the first time we've seen it? And all of that information should be there in a well-communicated article, because it's important in understanding the fundamental point of what you're trying to get across.
We've obviously mentioned headlines quite a lot so far. They're obviously very important for attracting people to read the news itself. Are there any kind of indicators or kind of warning signs we can look out for that might suggest that we should maybe question the accuracy of the actual piece?
If it sounds too good to be true, it is.
Yeah, that is a very good first step. So yeah, there's a lot around headlines and why it's difficult to, because it's firstly very easy for us to criticize headlines because we don't have to write them, and we're scientists, so we enjoy 6 pages on one very specific particular experiment that happened, and you can't condense that into a single headline. And so that's part of the issue, is that scientists love caveats. We like we've shown this in this particular model at this particular time with these particular things. And you don't have you can't accurately communicate that in a short form. So it's one of these things where you end up missing out some of the details. And it's firstly why the important thing is to read more than just the headline. And secondly, why you do need to be a little bit skeptical. So you mentioned our kind of steps our infographic for how to deal with headlines. And there's one element that's not on there that I think is quite important. And Katie kind of touched on this, the too good to be true kind of angle is, I think it's important to think about what emotion the title wants you to feel. I think that's a really important one, because if you just take a step back and think, this headline makes it sound like I should be angry or something like that, or if it's tugging at your heartstrings or something like that, then that can indicate that perhaps it's tailored to get that response from you and kind of get your attention more than it is to accurately present the news.
Yeah, humans are excellent communicators, and a lot of that comes down to having really great emotional perception and being able to grasp onto the emotion behind a point and using that to drive a point forward. And that's something that it's worthwhile being aware of. But in terms of like quick and easy things to remember with a headline, if it says things like potentially may in 10 years' time, anything like that probably means it's not been done in humans yet, and it is in that earlier stage. And always be careful with words like cancer and Alzheimer's and dementia, because they tend to, not all those three, but for example, Alzheimer's and dementia tend to get used interchangeably, but they are fundamentally separate. And there are lots of different types of cancer and stages and causes, that it's not a one size fits all. So if you are seeing a headline that's saying, cure for cancer in 10 years, what's more likely to be behind that headline is talking about one specific cancer that has been shown to work positively against a certain drug or whatever. The broad language tends to hide very, very specific things, because research does very, very specific things.
Yes, and it's often with those kind of things, again, they're quite emotive topics. Things like cancer is very emotive, and it's you want to feel like you're, that we're fighting back against these horrible diseases. And I think the thing to keep in mind is that we are. So if you hear something like, this drug could be a potential cure for cancer, don't join in with that conclusion, but we have made a significant step towards, treating a particular kind of cancer or something like that. So it's positive news. It's just, keeping it in the right kind of scale and context.
And that in itself, all of these steps, they are sensational in themselves. They don't need to be sensationalized out of context, which is like my real bugbear with this stuff. When there's a really sensationalized headline that, is going to revolutionize everything, and then it turns out to just be this small step towards doing that, it diminishes the sensational work
the
that
thing
they've
was
done.
cool
Yeah,
anyway.
exactly. Like, it's already cool. Stop adding glitter.
Do you think it's getting worse with sensationalists? Social media, everything, that's my job. Everything, we have to, make sure people click on a link. That's our job, to get those clicks. And so do you think that's driving more sensationalist headlines, or do you think this is something that's always existed? And so actually there's a more fundamental thing that needs to change?
I think that in the last 10 years, people consume information much quicker, and they are overstimulated and overwhelmed much more now due to social media and the way that we get our news than even 10 years ago. And a lot of that pressure for those snappy, clickbaity headlines, I think, has really come to a head in recent years, in probably the last 5 years, I would say. But I don't think it will just get worse and worse and worse, because I think the situation that it's led to now is this sort of fake news. You don't know what to believe. Everything's sensationalized and therefore nothing is situation, which isn't sustainable. And so I don't think it's going to get bigger and more sensationalized and more clickbaity. I think in reality there are going to be maybe more rules put in place, or people are going to be off-put by sensationalized headlines and therefore not click on them, and it will start to be this sort of reverse psychology effect. That's my personal prediction as a very optimistic person. Yes.
Yeah, I think I'm similarly optimistic. So I think first it's important to point out, so neither me nor Katie or anyone from Have You Heard themselves are journalists. So there's obviously a really different angle to look at.
Some of my best friends know journalists.
And so, we don't have a good idea of what the kind of internal landscape of journalism is at the moment. I generally think that that the internet and kind of this perception that there's a lot more fake news and things out there at the moment, I think is likely to be as a result of people being more aware of it. I think that pre-internet, there was all sorts of misinformation, huge amounts. Like word of mouth was the biggest source. Everyone knew facts from, again, I'm really sorry, Mum, but like my mum heard stories from people who would pass on this thing and the other. So it was misinformation was rife anyway. The internet just allowed us to all connect together, realize all of this kind of stuff that had been spread about,
but also spread it so much quicker.
Yes. And I think because we're still in the infancy of the internet, it's not been around that long, and I think there will be an adjustment period. And like Katie says, I imagine people get used to these sensationalized headlines, and then the demand for actual rigorous journalism will continue to increase as we go on, and it will kind of balance out a little bit. Yeah.
I think also the point where you're saying about word of mouth and your mum hears something and then tells you, I think that's particularly true, because when you're young, anything your parents say, you just take as face value, don't you? And then as you grow up, you then suddenly realise that you've learned and internalised something that's just not true. So I, for years, thought that you couldn't put your hand in the pay and display machines where the change falls out until you've heard the change fall out, because otherwise it will chop your hand off. And I thought that was a legitimate thing until I was like 19 or something, really embarrassing old.
Yeah.
Well, yeah, I've got a PhD now, and there's still stuff my mum says where I'm like, no, maybe she's got a point.
I saw a headline. No, I saw a quote recently about headlines that said, it was a general thing, not just about kind of science, but said that if a headline is a question, the answer is invariably no.
No.
Yes.
Certainly seems to ring true, and I'd guess in science as well that would be particularly true. You can't
definitely
simplify anything that much.
Have we discovered aliens? No, because the headline would be.
But you're way more likely. It would be way more likely to click on an article that says, "Have we discovered aliens?" than "We haven't discovered aliens."
Sure.
Yeah.
So you can see why that's the case.
There's another thing that was pointed out to me recently, and I can't for the life of me remember where I got it from, but someone pointed out the phrase that's used often in news articles, which is "concerns have been raised," and it's once you look out for it, you'll see it all the time, and it's a very interesting device that you can use as a journalist because it allows you to discuss something without necessarily having any evidence that is a controversial thing. You can elevate something to a controversial topic just by saying concerns have been raised. You don't need to cite a source on that. And it just means that anyone reading it who is ready to feel a particular way about a subject, you can get them to think that you're agreeing with them, even if there's no evidence of that thing. Mm-hmm. I've gone way off topic now. I'm sorry.
No, it's good. I think it's you do see those stuff like unattributed sources or sources say, and it's like, well, who? If it's someone with
Heinz ketchup, what kind of sauce?
If it's someone with authority, then you would name that person, I guess.
Yes, yeah.
Exactly.
So if you're not, then there must be a reason for that.
If you've not told us who, it's because it is Mr. and Mrs. Nobody of absolute no standing.
I know you gave the example before of the eggs and the kind of eggs influenced research. Do you guys have any more kind of specific examples that you've come across in your work kind of recently of stories being kind of exaggerated or distorted?
Oh, how long do you have?
Yeah, it's so we talk about a few different articles on each episode of our podcast, so we get through quite a lot, and generally speaking, all the kind of minor things that we'd do slightly differently are minor, and they don't change the overall aim of the article. So we recently did, as Katie was mentioning, an article on kind of dementia and Alzheimer's, and it's often a particular term that a scientist would use for a more general term, and you kind of exaggerate that way.
Or making a leap based on, say, there's a piece of research out there about memory and improving your memory, and then making the jump to this could be a cure for Alzheimer's, when none of the research is to do with neurodegenerative diseases, it's to do with how memory works. But there is that intuitive link, but that shouldn't be the headline. So one of our things that we've come across recently is seeing a particular word in a headline that is then not mentioned again for the entire article. And as soon as you're aware that can happen, you start seeing it everywhere. So I would encourage the listener to do that, because it's quite entertaining.
And I think one major area outside of biology that crops up a lot is, for some reason, not for some reason, for very good reasons, when space is mentioned in the news, it's always very exciting. People love stories about space and things. And I have this thing where, because of the way it's reported, I reckon if you asked people generally, have we found life on Mars? I think a lot of people would pause for a bit and have to really think about it, because I haven't even kept up with where we are with regards to finding water on Mars, because I feel like every 6 months an article would be published saying, oh, we found clear signs of life on Mars. And it's, we found frozen water crystals in certain bits of Mars and things like this. So that's one that always gets, the potential for alien life is one that always gets exaggerated and brought to the forefront when it's possibly not.
And that's something that annoys me, because like we said, I'm a biologist by training, but I'm an overall science enthusiast, because I'm asthmatic and wear glasses, so I'm not allowed to be anything else.
Yeah, society had already decided.
Yeah, there was no personal choice in this. But I'm really interested in space, and I think it was like 2 years ago there was something crazy that went on with space to do with a certain type of, I think it was like an image of the best image taken of somewhere, something cool, like cool stuff.
The black hole one?
Maybe the black hole, yeah. And I was reading it like, this is amazing, this sounds great. But the article that I was reading just scored very low on the sort of have you heard scale. And it was just making me more and more angry, because I couldn't find the information that I wanted to find about like how they did this. And I don't have that time to go and look into a field that I know nothing about to try and find that key information to see like how much I trust this image or whatever. And it just put my back right up. And every time anyone talked about it, I was like, if you can't provide me with better detail, I'm not talking to you about it. And but it just made me realize that Luke and I are in a very privileged position in that our understanding is biology, and a lot of the science headlines tend to be a biological, because there's that human link. And we have that standing that allows us to sort of look at it from within our own field to a degree, and know where to look a bit better. When you're coming from outside of that bubble and trying to navigate something that you don't know about but you are interested in, it can just be so frustrating to try and find information that just should be there. So we're big advocates for just, if the article itself can't tell us everything, please signpost to the original article or somewhere
where you can
find out more.
Sure. I saw an article this morning which is similar to this. It was about the headline, or the story was that if you have calorie labels on the left-hand side of packaging, you are less likely to buy the product. And if it's on the right, you are more likely to, right? So the reasoning was that left-hand side, you see that first. You read left to right, you see it first. Higher calories, you're put off. Whereas if it's on the right-hand side, you see the nice picture of the food, and then you see the calories, and you're not put off, right? So it seems
Interesting.
plausible. The headline didn't mention this. Went in to look at the paper. It was a difference of one person. So four people were more likely. 4 people would buy it if it was on the right-hand side, and 3 people would buy it if it's on the left-hand side. Not mentioned in the article. The article just said, put it on the left-hand side. And so I think like we have this thing where if we can kind of make sense intuitively of the, oh, well, yeah, that makes sense. It's on the left-hand side. Yeah, and there's a reason behind that. I guess what I'm getting at is like, how do we think about sample size or study size or the effect of is an event significant or not? Is that something we should be looking at more closely?
Completely. And I got really excited by that example that you said there, because you can see it logistically. And I was thinking, I know exactly the control that you would use. You would go to an Arabic country or somewhere where they speak Hebrew, where they read right to left, and then see if it matches. And then I'm just very, very disappointed that it was just one person. But yeah, you're completely right. You need to be aware of, it comes again to what is this done in, a sort of sub-level of that is like how reliable is that data? So how many times has it been repeated? If it's a sort of qualitative study, so something that's like yes or no, how many people is that done in? Is that statistically significant? Which is a key word in science, is the significance, and that's a word that holds weight compared to the layman's use of significance, which is sometimes something that gets missed as science gets sort of transcribed into the layman's terms.
Yeah, I think that's a really obvious example. I think if you looked at that and was like, oh, they did it on 7 people, you would viscerally just be like, I know 7 weird people who would do all sorts of things, and you wouldn't be able to draw a conclusion about everyone from those 7 people. And I think in that particular case, you would be suspicious because it's really easy to get lots of people, to get lots of numbers on that. There must be loads of people buying products and the left and right thing to be able to test it. So why have you only got so few? But as Katie says, firstly, linking to the article is very useful because in that situation, the basics would be to do some kind of significance testing, and the article should have already done that. So I have to imagine maybe it's based on something that isn't all that scientifically rigorous.
Sure.
I'd be curious if they actually linked to the article itself. But yes, you wouldn't be expected to do the maths yourself. You shouldn't work out if things are significant. The scientific article should do the numbers for you.
Yes.
And depending on what the article is, if we looked into it, it very well could be that the article itself says, oh, there was more on this side, but it's likely to just be random noise.
There's an interesting point about statistical analysis and sample size as well. You need to make sure that you're truthful about what your sample was. So say if you're doing a population-wide study, you need to report on what demographics you studied in terms of age and ethnicity and socioeconomic background. And that's to ensure that the correct conclusions are made. Because statistically, it's something like 1 in 7 people are Chinese. But if I looked out my window now and counted 7 people, it is unlikely that one of those people will be Chinese because of the socioeconomic demographic of where I live, which is in Manchester, which is in England. So you need to be aware not just of sample size, but of what kind of demographic it is studied on. And something that's really important with that's key in the last sort of 5 years with AI and machine learning is that if your sample type, which you train on, is incorrect, you will get incorrect data back out. And then that's a whole issue for example, when driverless cars were being tested, I think once there was it was mostly just white people that they recognised. And so the cars
It was
weren't very
wealthy
good.
Californians
Yes,
weren't
so good at recognizing any
Angeles.
sort of racial diversity, which is a problem in itself. And then you add to the fact that the car will therefore hit anyone that doesn't fit into the sort
more
of
likely
white
to.
male background, which is very problematic. And the same with Amazon tried to apply an AI to do their hiring, and they took out all genders and names, for example, and told the AI to, hire me the best candidate. And it was trained on the original, the people who were already working for whoever it was that I said. Was it Amazon?
Amazon,
It was Amazon, yeah. Whoever. So it said, like, this is everyone that we employ. We want to hire some new people. And because the people that they employed were mostly male, what they did is they created an AI that was biased against women. And then even when they took out any, like gender, so for example, a feminine name like Katie versus Mark, it would still pick up if you played like in a female hockey group or a typical gendered things, and just bin your application. So it's not just important for when you're reading an article to understand what it was done in terms of what the population it was done in. It's also important for the scientists, because, for example, if that original article that came out to do with identifying people for driverless cars sounds great, and then if they had appropriately said this was our sample, you would go, okay, I'm envisioning some problems that are going to happen later down the line.
Mm-hmm.
So it's all to do with this transparency.
Yeah, I think that's a really good point. I wouldn't, unless the numbers are extreme, you probably don't need to worry about it. The article should deal with the numbers and what's significant. But yes, if they make it clear how they've selected the people, that will give you a lot more information. And if they skip very quickly over how they got their samples, that is a reason to be a little bit skeptical.
And maybe look a little bit deeper if it's something that interests you.
And I guess like sometimes they're observing outcomes, right? So there might be population health stuff where they look at data 20 years after to see if there's a link. Is there a way we can kind of quickly identify like if something's causal or something's just kind of maybe almost like a coincidence of relationship, given that's accurately shown in articles?
So that's something that will be well discussed in the actual article, because that is the nature of these kind of population studies. And sometimes that doesn't get translated across very well into the actual sort of public eye. But I think Luke's correct in that if they talk about the conditions of the study, that shows that they've got nothing to hide. Whereas if they gloss over it, it's indicative that there may be some sort of issue. So when you look at, for example, death rates associated with this group A that were smokers and group B that weren't smokers, but they look at all deaths and not just smoke-related deaths or health-related deaths, then your data is going to be skewed by people that were hit by buses and fell out of a window. And that a lot of the time you will see in good written papers, there will be a section that says, just like, quick disclaimer, this was this, this was this. Mm-hmm. This was included.
And so, yeah, first on our list of things when you're looking through an article is what did they do? Or how did they find out the thing they found out? And like you say, so there's these things called kind of observational studies. So the idea is if you would hope that a news article would tell you a bit about what they did to find out whatever the headline is. And an observational study is anything that starts with, scientists looked over 20 years of data and noticed, that these two things tended to go hand in hand. And they are very valuable studies because that is a reason to go, oh, is there a link there? But that's the
and
point.
then more research is
yes,
done.
it's a start for further research into that thing. Not, you don't draw a causal conclusion at that point. And I think one of my favorite examples of this for kind of causality is
say the ice cream.
You can really easily demonstrate that ice creams cause drowning. That the number of ice creams sold on a particular day heavily correlates with the number of people that die by drowning.
Like, it's a beautiful correlation. Like, it is like straight there.
And yeah, so it's based on observational data that you notice over a long period of time that this happens, and the kind of common sense interpretation of that is that it's just to do with hot weather. When it's hot, more people swim and more people buy ice creams. So there's no causal link between those two things. So that would, for example, cause a scientist to go, oh, how can we look into this? Well, if we just randomly choose 10 parks in the UK and stop ice cream vans from going to those parks, is there a noticeable decrease in drownings and things like that? That's when you start to then be able to identify that taking a particular action seems to have a particular effect, and that's more causal. But yes, it's quite common for that kind of subtlety to get lost, particularly in the headline. But you'd hope that the article itself, if you read a couple of paragraphs in, would tell you what they were doing.
And a good communication on something that's an observational study will tend to end with, this is what they are going to do in the future.
Yeah.
But it's also worth noting that these kind of observational studies, though they frequently happen at the sort of start of that scientific pipeline as identifying something to look at, sometimes they happen at the end as well. So if a link between X and Y has been shown experimentally in a small, petri dish level, people will start to look at the sort of population level data to see if there is something that will link the two, and that gives you more encouragement to pursue that long pipeline.
Is there any like kind of take-home advice that you would want to leave the listener with, like when they're reading an article, some top tips?
So when you're typically encountering news, so it'll be scrolling through Facebook, someone's shared an article, you'll see headline first. I think the most important thing is, if it's something that you're going to take on board, if it's something you're going to pay attention to,
or if you're going to talk about it with your friends, if you're going to say, did you see that blah blah is blah blah, if you want to be a good friend, you'll have clicked on that article.
Yeah, don't share it without knowing what it's about. But yeah, if you're going to take on that article, just give it a click, read a couple of paragraphs, because often a lot of kind of very exaggerated articles that don't have the same kind of journalistic rigor as maybe a newspaper article or something like that will fall apart in the first couple of paragraphs. You'll realize that, they're talking about one thing and then it quickly goes off into something else. I think it's important to think about how you react to it emotionally. Is it trying to invoke a particular reaction from you? And then when you get into the article, we typically go for kind of three major things, which is how. So how was it done? Main ones are things like, was it in an animal? Was it in people? How many? Was it over a long period of time in the past, just kind of noticing a pattern? Or did someone think, I have a hypothesis, I'm going to test it? The next thing to consider is who. So who did the research? Where are they from? What's their background? Are they someone
who
that
funds it?
Yeah. Are
Who
they qualified?
supports
Who's told them to do it? Things like that. And then the final one, which I think is probably one that's often overlooked and is, I think, quite an important one, is who else. So who else agrees? Is there someone that the article's talking about that's completely separate from the group that did the research, but is knowledgeable in that field, who can say, you know what, they did this in a very sensible way. I'm confident their results sound about right with what we know in the field, or, this was a surprise, but their results look rigorous and they've taken into account the things that I would want them to, things like that. That's a really good sign of a good article. So I think they're the major things.
That's all we have time for today. A huge thank you to both Katie and Leek for their insight. You can check out the Have You Heard team on Twitter at HaveYouHeardUK. Whilst you're there, why not check us out too? You can find us there at UOMSciEng. We're also on Facebook, Instagram and LinkedIn. The next time you see a science news piece, we hope you feel a little bit more informed and have the skills you need to decipher whether or not you can trust the piece. Join us next time in the Season 2 finale of The Buzz.